Linear Motion 2013. A lift ascends from rest, constant acceleration f, until it reaches a speed of v. It continues at this speed for t1 seconds, we're given this t1, and then decelerates uniformly to rest with deceleration f. Part 1, you're asked to draw a speed time graph. So from rest to v, constant acceleration, and maybe we try and get a straight line for constant acceleration, and then decelerates with the same acceleration or deceleration back down to 0. So these accelerations are the same, so the time in these intervals, same times. They're going to be the same times. We're told the time in the middle one is t1. This is v. So if we say that the total time is t, what's left is t. If we take t1 away, that's going to be what is left. And take t1 away, t minus t1, and therefore there's two triangles with the same time, so t minus t1 divided by 2 is the time intervals in here and over here. And that's the speed time graph. Let's look at part 2. Part 2, we're asked to show that velocity, or v, is equal to half f by t minus t1. Well, v is equal to u plus at. The velocity, v, is equal to 0, it's my initial velocity here, plus the acceleration, which is f, times t, which we've actually worked out above, is t minus t1 over 2. We can take that 2 out and make it 1 over 2, so velocity is equal to a half f by t minus t1. That's what they're looking for. Part 3, we're asked to show that t1 is equal to the square root of t squared minus 4d over f. Okay, so we have d, so we're looking at distance here. So we're looking for the total distance is the area of the shapes. So the distance here is, well, these triangles are the same, so we can put them together and make them a rectangle. The base of the triangles we had up here was t minus t1 over 2. T minus t1 over 2 is the base of those triangles, multiplied by the height, which is v, which is this guy, which I'll write as f over 2 times t minus t1. And then the area of the rectangle is the base, which is t1, by the height, which again is f over 2 by t minus t1. You can see here we want a 4d in the question, or in the answer. So let's get rid of these 2's on the bottom here by multiplying by 4, and we get our 4d. 4d is equal to f times t minus t1 by t minus t1. And that's going to be equal to 2. I'm going to still have a 2 here. The 4 multiplied by 4 will give me a 2 on top. 2 times f times t1 by t minus t1. That shouldn't be an equal sign, it's a plus sign. So let's see what happens. Well, we can divide by f, definitely. We want 4d over f, so now we have the 4d over the f. 4d over f is equal to, remove the brackets, t squared minus t by t1 twice, plus t1 squared, plus 2t times 2t1 times t, which is 2t t1. That's the same as that one. And then 2t1 by minus t1 is minus 2t1 to be squared. So what are we left with here? We're left with 4d over f is equal to minus t. See, I left out my squared there, didn't I? So I'm going to be minus t1 squared plus t squared. Yeah, that's all we're left with there. So if I bring the 4d across to meet the t squared, I'm going to get t squared minus 4d over f. And if I bring the t1 squared to the left, I'm going to have t1 squared. And now if I get the square root of both sides, I have my answer we can see here. So t1 is equal to the square root of t squared minus 4d over f.